So I just want you to watch for a minute. Put your pencil down and watch. What is 5 times 5? 25. Very good. What else is it? How else could I think about it? Yeah, 5 squared. Right? Good. What about 3 times 3 squared? How could I rewrite that? How could I think about that? Good. 3 times 9. What else? And what is 3 times 9? 27. I'm not even actually worried about the number answer right now. We're looking for a different pattern. Noah, are you with us here? How else can I write it? How do I rewrite 3 squared?
You can write 5 times 5 plus x.
Yeah, I could. What else could I do? How do I rewrite 3 squared? 9 is one way. What's another way? Like, what does it actually mean? Cool. 3 times 3. Good. 3 squared. Okay, I'm going to write it up here. 3 squared means 3 times itself. Right? Twice. If it was 3 to the 4, it'd be 3 times 3 times 3 times 3. So this is like 3 times 3 times 3. There's my 3 squared. What's another way of writing 3 times 3 times 3? Cole, what do you think? Yeah, very good. 3 cubed. And 3 cubed is 27. Do you agree with that? So what's the pattern here that we can notice? This may be something you've never seen before. When I'm multiplying, okay, and these things have the same base, so it's 3 and 3, right? 3 and 3. Well, there's 1 3 here, and there's 2 here, so I ended up with 3 of them in total. Does that make sense? Do you see what I'm getting at here, Tariq? What do you think? Or are you tuning me out? This is only going to take a second, but this could help you remember how we're going to do what we do next. We're doing distributive property again, but it's a little bit different from what we did on Friday. So I'm just going to go over it again. If I'm multiplying things like this and they have exponents, I can add the exponents. Let me do another example. 5 squared times 5 cubed. You're never going to have to do it with big numbers like this, but this is like 5 times 5 times 5 times 5 times 5, right? There's 3 from the 5 cubed and 2 from the 5 squared. Caleb, what do you think about that? Does that make sense? Yeah. So how many do I have total? What do you think, Caleb? 5. I have 5 total, so it's 5 to the 5. 2 plus 3. 2 from here, 3 from here, 5 total. See what I'm getting at? So we're adding the exponents. But if it was 5 squared times 4 cubed, then you can't do it. There's nothing you can do to simplify that. So let's take a look at this. I want you to write this down. Just example 1, question A. How do I rewrite A times A? This is important because you're going to have to do this. And if you write down this example, you can look back at it later and say, how did we do it? When we're multiplying variables, what was it that we did? Okay, so I think it's important for you to have this in your notes. How would you rewrite A times A? There's kind of a 1 times 1 going on, you're right, but no, we're not going to rewrite it that way. A squared. I'm going to come back and just talk about what you just said for a minute, because it is something that sometimes people get tripped up on. So I'm going to put this aside for a second and talk about something else. When I have A plus A, people think, oh, there's a 1 there, right? So it's a 1 plus 1, which is 2. Well, what's my mistake that I've made here? A could be any number. Good. And you're on to something. So if you do something like this, you've mixed up two different ideas. You've replaced A with 1, and that's not how it works. A has a coefficient of 1 in front of it. The A doesn't disappear. It's like 1A. 1A plus 1A is 2 A's, not 2. Does that make sense? So when you're thinking about a letter just written on its own, yes, the coefficient's 1. It's 1x, but the x is still there. Like the x doesn't disappear. Does that make sense? So same thing over here. A doesn't disappear. It's 1A times 1A, but we're going to write it as A squared. Something times itself. So what would this one be? Y times y squared. Again, we can think about the example that we just did with the 3. Y times y squared. Anybody have any ideas? So I could do it like this. Y times y times y. Right? Y squared is y times y. And I've got this one out here. So I've got 1 from here and 2 from here. So how many do I have total? So how would I write that? Y cubed. This might seem like a strange thing, but if you practice it for a day, you can do it. And it's not going to get really harder for us. So you only have to know how to do it with a few smaller numbers. And then what about this one? How do I do this? So when I'm multiplying and there's numbers involved, I'm going to split up the different parts and do them differently. I'm going to do 6 times 2 by itself. What's 6 times 2? What is it? I didn't hear. 12? And what is x times x? We just did this. Close. X squared. That makes sense? Kind of, at least. This can be a tricky one, but luckily enough, it doesn't get harder than this. And so, if you have to, you can kind of just practice it for today until you're getting it, and then just try to remember it. Instead of using like the techniques and the tricks that we were using for this one, you might just want to kind of practice it enough times that you've got it. Before we move on and do some harder examples, not harder, but some bigger examples with distributive property, I'm just going to point out one more thing. X plus x is 2x. X times x is x squared. So they're very different, but it's easy to mix up. So what we're going to do today and tomorrow is all about remembering collecting like terms is when you're just adding apples, adding hamburgers, adding French fries. Distributive property is when you're multiplying, and if you multiply with variables, that has something to do with the exponent. Okay, let's try this. This is the same as Friday, this question. Who remembers from Friday what our strategy was for this kind of a question?
Do 3 times 2x.
Uh-huh.
And get 6x
So there you go. There's our answer. What was your strategy, though? Just multiply. Excuse me. What did we do on, good, very good. What did we do on Friday? Does anybody remember? Spencer and I talked about this. We talked about like a hiking pack or something like that. Didn't we talk about that? Like an apple and a banana and a bottled water. Remember that vaguely? And I was like, everybody gets 1 apple and 2 bananas and 3 bottles of water. And then I'm going to pack 5 bags for them. So this is like everybody's got 2 X's and a -1, and there's 3 packs of those things. So you get 3 of each of those things. So 3 of the 2 X's and 3 of the -1. You're multiplying everything in the brackets by that number out front. Okay, try the next one. What's different about this question? How did it just change, Tariq? I scribbled on this one so you can't see it. Take a look at question A and take a look at question B. 3 has an X, so how is that going to change your answer? Don't tell me that, but think about that. But write it down. X times X. Oops. So what happens for this first part? The idea is the same, folks. For distributive property, I multiply what's in front by everything inside the brackets. What do I get for the first part? Caleb, what did you get?
3x times 2x.
And what is it?
6x.
So 3 times 2 is 6. And then some people might have put 6x. But if you heard Caleb, why is it 6x squared? Because it's x times x. So that's the new part today that you just have to catch. But it's the same every time. And again, we're not going to make it, it's not really getting more complicated. So it's doable if you just work through it. And then what is 3x times -1? Cool? Not sure? Liam, what'd you get for the second part of this? So 6x squared, what's the rest? -3. -3, and I'm going to keep this x. So you want it to look like that. Spencer, what do you think? What do you think? For that answer, did you get it written down? No, did you get it written down? This is the kind of math that can be tricky. You want to have an example that you can follow. So make sure you've written it down. 3x times 2x minus 1 is 6x squared minus 3x. Okay, let's try another one. So you've seen a couple of examples now. You might be able to try it yourself. This is where you get to see if you can use the example we just did as a model for how to do the next one.
What's missing?
Okay, so listen carefully. I'm going to multiply 4x by both things. Some people they're focusing too much on the one part of it and we forget to multiply by the second part. Okay, so when I multiply the first part, 4x times x should be 4x squared. Don't forget that squared. It's really easy to forget it. But that's what we're trying to get today. And then 4x times 5, does anybody know what that is? Very good. 20x. So we keep the x. We don't add on to it. There's no other x's, right? In this case, there were 2 x's, so it became squared. But in this case, I only have 1. There's no x there. And I do 4 times 5, which gives me 20. Okay, let's try a couple more.
So we got a kilo, like here, and you would fill 5 to 20 x. Not x. This one became a squared. This one, so it just stays the same. It doesn't just.
Okay, so hopefully you got something like this. A times A is A squared. A lot of people are dropping the A in the second one and doing something like this. But when I did A times negative 2, A doesn't disappear. It doesn't become very good. It doesn't become A squared, but it doesn't disappear. We have to keep it. One more. We'll do this one together. So watch for a minute. Something else to think about is notice how all 3 of these, they're not like terms. Do you see what I mean by that? We can't add them together. Does that make sense? So when I multiply, they should still all be different. That's a tip. So when I multiply the 2x through, what am I going to get? So for the first one, what's 2 times 5? Okay, so I do that, and what's x times x squared? We did something like this already. What were you going to say, Tariq? Good, very good. So x cubed. Moving on to the next one, we're done the first one. 2x times negative 3x. So 2 times negative 3, what's that? And x times x, we've done that a bunch of times. That should be x squared. And then 2 times 9 is 18. And 18x, very good, Tariq. Right, we keep the x. So look for a couple of patterns here. There were 3 things inside the bracket. I have 3 things in my answer. Right, that always has to be. We can't have one of them disappear. If you can remember that, that might help you catch some mistakes. Any questions about that? Okay, I'm going to let you practice a few. Again, there's question number 2 is a little bit different, but I'm going to let you practice a few of these first before we move on to that. So this is part of the lesson that we were doing before. If you want to just watch, you can watch, but I want you to pay attention. This is like we did this on Friday. Okay? So basically it's one question that has two parts. I do each part the same, but I'm going to have some extra work to do at the end. So for this part, I do 2x times 3x and 2x times negative 1. That's what we've already been doing. What's 2x times 3x? Why is it 6x squared? Are you starting to get more used to this? I hope seeing it over and over again, you start to get more used to it. 2 times 3 is 6. X times x is x squared. 2x times negative 1. Minus 2x. I multiplied 2x by the bracket, so I stop, and now I can multiply the 5 through the second bracket. Is that okay? So what's 5 times x? It's just 5x. 5 times 2 is 10. But you can look at, like, why is it x squared here, but it's not x squared there? Why do you think? Cool? Because I was multiplying by x here and I'm not here. 5 is just 5. Good. Tricky stuff, but it's the same over and over again. And what do I do now? Well, I've got like terms. I've got two terms that are just x, not x squared, just x. So I can add them together. 6x squared, 5 minus 2 is 3. I had 5 x's. I took away 2 x's. I've got 3 left. Plus 10. Same thing I would do here. I'm not actually going to do this one. I'm just going to talk about it. I would do 5a times each of those, and then negative a times each of those. And I would get a whole bunch of terms. And that's where you have to look for like terms, because I multiplied twice. So there might be like terms to add together. So I want you to try question 2a from your practice sheet now. Even if you didn't finish the one from 1, try 2a.